Alrighty, so we are back with part two. In this part, we are going to talk about the assembly feature. I'm going to go through kind of a lot of stuff relatively quickly. Assemblies can get kind of complicated, but I'm going to try to kind of scratch the surface on the basics, and then we're going to kind of rely on some of our projects to teach a little bit more of the specifics and kind of the how to use it. So first things first, we're not going to work in this part studio. We're going to create a new part studio real fast because I need to create some sample parts to kind of demonstrate the assembly features. So I'm going to create, go to the top here, go to sketch, and I don't know, I'm going to create some rectangles. Attach them to each other. And I'm gonna call this like some sort of like little frame, basically. All right, and then I'm gonna use the okay here. I'm gonna use the extrude individual feature to create separate parts with all these. Go like 2 inches, and then we'll be good. Okay, so this is our part studio. Let's say we're designing the frame of a robot, right? And we're putting all these parts together, and we're modeling them together in a part studio. So I'm going to rename this part studio and call it frame, and then we're going to switch over here to assembly 1. I'm going to drag this back to the beginning. Okay, so the first thing you need to understand about assemblies is how to put stuff in the assembly. So you go to the insert button. This is the tool that you're going to use to insert parts into your assembly. So by default, it's going to start you on the current document tab. And you can see here all of the part studios that we have in our document. If we click these little arrows, it'll expand and it shows all the individual parts in the part studio. And same thing here with our first part studio. Keep in mind these little buttons here, these are filters. By default, only individual parts are shown. There are some things that will use composite parts, which is going to be kind of a different type. You'll have to click the button if you want to see it. So not everything will show up here in this list by default. So it's just kind of something to be aware of. We will definitely run into that in some of our design projects in the coming weeks, and so I'll cover it again then. If you are trying to place a sub-assembly into an assembly, so let's say we have more than one assembly in this document, and you did a small little assembly, and then you want to take that little assembly and place it into a bigger assembly, you just switch over here to assemblies. Now we don't have any other assemblies to work with, so that's not a thing, but that is definitely something you will do on occasion. So there's 2 ways to place part studios in. You can select the part studio itself and it will place all the parts at once. Or you can select individual parts and place them in. So but to start here, we're gonna create we're gonna drop in the whole part studio. So I'm just gonna click on the frame part studio. You'll notice it's kind of highlighted and it shows up over here. I can pan and zoom and everything over here while I'm moving around, but it just follows my mouse around. If I click, it will place these parts wherever I click. You'll notice they're all kind of stuck together. Now, because this is the first time that I've placed parts in an assembly, I kind of want to use these parts as a basis for the rest of my assembly. So I actually don't want to place them down just anywhere. Oops, I just accidentally right-clicked. I don't want to just place them down anywhere. I want them to be placed in the same location relative to the origin that they were in the part studio. So if I just don't click over here and I keep my mouse inside of this dialog box, you'll notice the parts are not moving, but as soon as I move my mouse outside of the dialog box, they snap to my mouse. So if I keep my mouse inside this box and then just click OK, you'll notice the parts are nicely just right on the corner of the origin, which if I switch to my part studio, you'll notice exact same place, right? That is highly useful. So for our robots, typically the origin point is the floor, and it's in the center of the robot, and everything is based off that origin, and that really saves us a lot of headaches in terms of figuring out where parts are in relation to each other and making sure they're in the correct spot on the robot, is that we know where the origin is relative to the whole robot assembly. So it's pretty important when you're placing your first parts into a new assembly that you you don't place them down just randomly. You actually let them snap to the origin the way that they do if you keep your mouse inside the dialog. So something to note here, these parts are not attached to anything. So if I click and drag on them, they'll move, right? It's just like a sketch where if I place a line and I don't dimension the line, I don't constrain the line I can just click and drag it and move it around and it's undefined. So I'm going to undo that and just let the part stay kind of where it's supposed to be. So what I can do is I can lock these parts in place. So what I can do is right click on a part and hit this fix button. Now notice I can't click and drag on it anymore because it's fixed. I can click and drag on this one because this one is not fixed. I'm going to undo that. So I can just go through and I can fix all of these. Now this is bad, okay? I really am not going to go exactly into why this is bad, because it gets into, if I place this assembly into another assembly, not all of these fixes will still be there, and so parts will just be floating in space. That's the short answer. I don't really want to go through the steps to demonstrate that at the moment, but basically you should only have one fixed part per assembly is generally good practice. So what I'm going to do is I'm going to unfix this part and this part over here. This part here seems like it's kind of the more important piece. It's not, they're not in order necessarily, but I'm going to leave this part fixed. So this part can't move and these parts can move. So I'm going to Control Z to bring those back. So we've got one fixed part that can't move and two other parts that can float. So we're going to use a feature called the group feature, which is this button up here. You can search it in the bar. And you basically just select parts that you want to all be grouped and not move relative to each other. Group is super useful for parts that are in the same part studio. If you're in a part studio and you model them where they're supposed to be in relation to each other, grouping them once you get into an assembly is a good practice. So you'll notice now this part doesn't move, this part doesn't move, this part doesn't move. If I unground or unfix, sorry, it's called ground in Autodesk Inventor, and that's what I'm used to. So it's called fix in Onshape. If I unfix the base part here, I can move all these parts. They move with each other, but they still move, right? So I'm going to undo that, and then I'm going to go back to fixing this part. So this is basically how you attach your kind of base parts in your frame. Now, the thing to understand is that if I don't model all of these parts in relation to each other in my features, in my part studio, then they won't be in the correct spots when I go to the assembly. There's nothing magical about this that just makes them appear in the right spot. It's all just, do you model them in the correct spot in the in the part studio? So let's go in here and let's actually change something in the part studio. Let's edit this sketch and let's make this part like just a little bit longer. We'll make it 7 inches instead of 6. Click OK. If we go back to our assembly, you'll notice it all updates, right? Because all of the positions of the parts relative to the origin changed in my part studio, so they change in the assembly as well. Okay, so let's do another thing here. So let's show how you would place a single part. So let's say these are 3 frame members, but let's say I need another one, right? Like let's say these are not the whole, that's not the whole story. So let's go insert, let's go to frame. I can click on any of these parts. Let's grab part 1 here. And now you'll notice if I keep my mouse inside the dialog box, the part just wants to show up just overlapped with the one that's already there. So obviously I don't want that because I can't have 2 parts in the same place. That's bad. So I'm just going to kind of just place this off in space somewhere by clicking. And then I click OK on the dialog box. And then this is obviously floating, and so it's just kind of floating around. Now, this is how you're going to place a lot of your parts. So like really closely related things like your frame and stuff like that, you're going to place in these big blocks and then just group them. But individual parts like bearings and screws and motors and stuff like that is, you know, not so quite closely related with the structure of your robot, you're going to have to place them in individually, and you're going to have to attach them to other parts. So that is something that you'll need to be able to do. So we're going to use something called a mate, and essentially a mate is very similar to a constraint in a sketch. It's basically just a mathematical rule that a part has to follow in order to be positioned in an assembly. So basically, whenever the assembly gets updated, which happens periodically by the server, it will basically go through and it will position parts in such a way that they satisfy all of the logical rules that you apply to them in the form of mates. So it's basically, if just think of it just like constraints in a sketch, except this is happening in 3 dimensions and it's for parts instead of just like lines and circles and stuff. Now, the one thing I will note here, this is probably the biggest difference between Onshape and other CAD software. So if you're coming from a different piece of CAD software, this is going to be probably the biggest learning curve over other things in Onshape, which might be very similar to other CAD software. The other thing is, if you are only learning Onshape and you don't know any other CAD, don't get too locked into this assembly method, because this is unique to almost every other CAD program. And when you guys get into like a job and stuff, you're probably not going to be using Onshape. You're probably going to be using, I don't know, SolidWorks or Inventor or Creo or whatever. You're going to be using some other piece of CAD software, and it's not going to work this way. So that's just something to note. This is a little bit weird, a little bit unique to Onshape. So I'm going to teach you how this works, but you'll have to learn a different assembly system for a different piece of CAD software. Okay, so let's talk about mate connectors for a second. In part 1, we created like a quick mate connector as a custom thing, but there are actually built-in mate connectors. So every piece of geometry, right? It could be this face, could be this edge, right? It could be something something very just any little facet or some curved surface or something. They all have mate connectors. They're all just built in, and you can't see them by default because there's no reason for them to be displayed on your screen. But just keep in mind they're there, right? You're not you're never really creating them unless you're adding a custom one in a part studio like we did in part 1. So basically, the way that you attach parts to each other in an assembly is you make connections between mate connectors, and you're basically just selecting mate connectors that are already on the part, and then you're connecting them together. So let's talk about what that means. So if I select one of these buttons up here, these are all different types of mates, kind of like the different types of constraints. And we're going to start over here on the left with a fastened mate. This is the one that you're going to use most of the time. Basically, it connects 2 mate connectors together with a relationship between them in terms of like position and angle and stuff, which I'll go over here in a bit. But it basically connects them together in such a way where they don't move at all in relation to each other, and they also don't rotate relative to each other. So that's pretty important, because while in a sketch, it is super important to get everything fully constrained. In an assembly, that's not quite as important, because sometimes I want to leave parts able to move, so I can click and drag them and show how my assembly moves. So if you think about like a robot with an arm on it or something, right, or a turret, like I want to be able to click and drag on that and move that around and see how the robot moves. I can rotate the arm around and make sure it doesn't hit another part of my robot, for example. So in an assembly, you often don't want to fully constrain everything. Like all your parts should have very defined locations, but like if you've got a moving part that you want to move, it's okay to allow that part to move in the specific way that it'll actually move in real life. So fastened is what you're going to use if you want to just lock parts down and not allow them to move, but there are other mate types that allow parts to move. So let's do an easy one here real quick. Let's just let's hover over this face of this part. Now you'll notice right off the bat, the face highlights, you've got these like kind of round dots at the corners of the face, and then right in the middle of the edges, you've got these little square dots, and I've got this kind of like yellow and multicolored like thing that's just like snapping around as I move my mouse. So the thing to understand is this little multicolored display here, this is a mate connector. And all that's happening as I move my mouse around is it's highlighting mate connectors that already exist on the part. I'm not creating a mate connector or anything like that. It's just highlighting mate connectors that are already there. And so by default, on a flat face like we're looking at now, Onshape creates some mate connectors for us just automatically. So it creates one at every corner. That's easy. It creates one right in the center of the face. That's often useful, and it creates one at the center of every edge, which is sometimes useful as well. So the thing to understand here is that even though my mouse, like for now, like right now, you see the mate connector is in the middle of this face, but my mouse is like way up and to the left of it. If I click now, I am not selecting where my mouse is on the screen. That is key. I am selecting the mate connector that is currently highlighted on my screen. If you're new to CAD entirely, this may not be a problem for you. If you're coming from another piece of CAD software, I can tell you right now this will mess you up. So I'm kind of pushing this point home because it's very important that you understand that wherever the mate connector is highlighted on your screen, if you click, that is what it is going to select. It is not the position of your mouse has no importance here. So like let's just do one real quick. Let's select this one right here in the middle. So as soon as I click, you see it kind of highlights the face and it highlights this little mate connector, and there's kind of a ghost of it. And you'll see up here in this mate connectors box, it added this mate connector to the list. Now we need to find another mate connector to attach this mate connector to. So let's just pick the center one from this top face here. That's easy. Click there. You'll notice the parts are kind of sunk into each other. So because it's not going the right direction. So all you have to do is click this button, flip primary axis, or this button up here, same thing. It'll flip the direction of the part. If I want to change the orientation of the part, I can click this reorient button, and it turns the part by 90 degrees every time you click it. So that's useful as well. And then if I click OK and close out the dialog, over here in the mate features list, we've got our group that we created earlier. Then now you can see there's a fastened mate. And if I click and drag on this part, I can't move it. It's completely locked in place. Okay, let's do another one. Show some more ways we can use this. I'm going to place another part down. So one thing that can be kind of difficult to do, especially for people that are new to Onshape, is to make some corner joints. So let's show how that works. Let's do another mate, fasten mate. So let's hover over the end of this, and I want to demonstrate something real quick. So there are some key features of mate connectors. So the first one is this like kind of yellow disc in the middle. This yellow disc here represents a plane that the mate connector it kind of is lying on, right? So every mate connector kind of has a plane that it's lying on, and then every mate connector has kind of a coordinate system. You can see this blue, red, green line. This is basically an XYZ coordinate system. Z is blue, X is red, and Y is green. And every mate connector has kind of an XYZ coordinate system that it uses to position itself. So let's kind of look at how the mate connector is positioned depending on what we select. So if I hover my mouse over this face and then I move my mouse towards the corner, you'll notice the mate connector is snapped onto that corner. Now, pay attention to what orientation the little disc is pointed in. You see how it's like the plane of the disc is on the same plane as the face that I'm hovering over. Now, if I come up here on top and I put my mouse on this top plane and I move it towards this corner, you'll notice same corner, but now the mate connector's little disc is coplanar with this top face. So that's a key thing when you're assembling an Onshape. In other CAD softwares, it doesn't necessarily matter where you move your mouse from. It only matters where your current mouse position is. Whereas in Onshape, it matters where you came from, right? If you have a face highlighted and then you move to the corner, it's going to select a mate connector on the corner of that face. Whereas if you're highlighting a different face, it's going to reorient the mate connector, right? Because the mate connector does not belong to this like little corner vertex. It actually matters which face the mate connector belongs to. So that's kind of a key feature that will trip you up if you're not paying attention. So just look at your screen, make sure you're paying attention to what direction this mate connector is actually facing, and then you'll be okay. So let's actually go ahead and select this corner here though. And we want to take this face and we want this corner to be attached to this corner with this part sticking out kind of this way, right? So we're just gonna come over here, we're gonna select this face, bring our mouse to the corner and click. And then we gotta reorient the part. So we're gonna flip it, and then we gotta rotate it 3 times, and then now the part is kind of making a corner joint. This is kind of an unintuitive way to do it if you're used to other CAD software, but the nice thing is it allows you to do it in one mate, right? This part is completely locked down. I can't move it. All I had to do was place one fastened mate. All right, let's do a couple other things. So if we want to come down here, it's fasten mate, right? Click on it, click edit. We can make changes to it. So let's say we wanted a gap between these parts. We still want the corners lined up, but we wanted a gap. So if we click the offset button, we can add an offset in any direction. So we can add an offset in Z, Y, or X. So now keep in mind this coordinate system is relative to the first part that we clicked, and so that's something to note. And I want to move this part this way like 1/8 of an inch. So you can see the Z-axis here is pointing in that direction. So we want to move it along the Z-axis. Positive Z is the direction this little line is facing. So we actually want to go negative Z. So I'm going to go to the Z box, type in negative 0.125 inches, and then press enter. You'll notice our part moves. There's a little gap here. That's all good. So I can use this feature to add offsets on any axis. I can also rotate by an angle, rotate about a particular angle if I want to, and reposition this part using just this one mate feature. All right, let's demonstrate a couple of other things really quickly. I'm actually going to bring in another part really quickly. So I'm going to show you how to bring in a part from an Onshape document that somebody has shared with you. So I'm going to go over here to revrobotics.com and search 1-inch brackets. Go to here. There should be Onshape links on this page. So if we scroll down, we just pick, I don't know, any bracket. Doesn't really matter which one. We're just going to pick a random one. We'll just do this one here. We click on it. It opens up an Onshape link. And we've got this part. Oh, actually, this is not a part. Actually, it doesn't matter which one we click. I don't want to click that one. I want this one. Yeah, there we go. Okay, this is better. Okay, so we've got this Onshape part. Now, if we go up here to the address bar and I'm going to hit Control-C to copy this to my clipboard, then we go back to our Onshape link. And we go back to Insert, and we go to Other Documents, and we just paste the URL in this box here, and then press Enter. It'll show up in this list. We can click on it. This is a part studio. Now the part studio only has one part in it, so we actually want to select the individual part, and then we can place it in our assembly. Now I can't edit this part because it was shared with me, but I don't have to remodel this part from scratch, and more importantly, I don't have to download a model of it and then import it into Onshape. So sharing parts through links makes it super easy. MK CAD is even one step easier than that, so I'll show you how to use that as well here in a minute. So let's constrain this part. We're going to use, so the right way to constrain this part in place is to use custom mate connectors, which I would demonstrate, but it's essentially the same thing as just doing these fasten mates. So I'm actually intentionally not going to use the custom mate connectors to show you how to kind of constrain a weird part like this. So in this case, I want, this part has this clipped corner, right, which is used to eliminate a sharp edge and save a little bit of weight. But I want to attach, if this corner wasn't clipped, if there was a sharp corner here, I want to attach that to the top of this part on this corner. Now, if I use a fasten mate, I can select some points, but you'll notice there's no mate connector like in this virtual corner in space, right? I can select the midpoints of edges and stuff like that, and that's all well and good, but that's not super helpful to me for what I need to do right now. So typically, if I have this part, there's some holes, and I could constrain one. I could mate one hole, the center of one hole to another, right? And that would be an easy way to constrain this. But I'm going to use this to demonstrate just another type of mate connector. So let's go over here, and if you click on any of these mate types, you can just change this drop-down box and it'll switch which mate type it is. So clicking one of these buttons versus clicking this drop-down is really no different. I generally just hit the M key and it'll pop up, it'll default to fastened, and then I can just select which one I want. So the one we're interested in now is planar. So planar is a bit of a weird one, and if you're used to other CAD software, this one may feel a little bit more familiar to you. But the one thing I will tell you, if you're coming from another piece of CAD software, you are going to be very tempted to use planar for everything. Don't do it. You should be using fastened for 90% of the mates in your assembly. So don't take the bait. Don't use planar for everything. Planar should be used very sparingly. There's only a few situations where planar is actually the right answer. Generally speaking, there is a way to make the fastened one work. You should use that if you can. However, in this case, I specifically want to demonstrate planar, so I'm just going to do it. Now, the one weird thing about the planar mate is that it kind of doesn't actually matter which mate connector I pick. I can pick this one as long as it's on the face. I can pick that one. I can pick that one. I can pick any of these hole centers that's kind of floating around. I can pick the one in the middle of the face. I can pick this one in the middle of the edge as long as it's facing the right direction, et cetera, et cetera. I can pick any of these mate connectors, and it doesn't actually matter because the only thing that the mate connector is going to use is the disc, like the flat face of the mate connector, rather than any of the axes. It's not going to use the Z axis or the Y axis or it's not going to use any of that stuff. It's just going to use the flat face. So it's a little bit weird because it feels like you're over specifying this mate, and that's kind of because you are. It's just important to understand that it's going to ignore some of the it's going to ignore specifically which mate connector you're picking. It's just going to use the face that mate connector was from, but you can't select the face directly. That's if you're coming from another CAD program, you're going to want to select the face directly, and you can't. So I'm just going to pick the one in the middle because that feels right to me. We won't select. Come on, there we go. And then I'll come up here and I'm going to select this face. And I'm going to flip them around because I want them to be facing each other. And you'll notice this part is attached to this face. I'm going to click OK. I'm going to close out of this dialog. You'll notice I can move it around, right? It is all these two faces are always going to stay on each other, right? But I can move it around in plane, right? And that's why it's a planar mate, right? Because it's constraining only along one plane, but I can slide around that plane basically. And I can also rotate. It's a little bit hard to demonstrate, but this part can also rotate as well. You can edit the thing. You can add offsets and things like that. But you can probably figure that out if you go in and do that. So I'm not going to bother really demonstrating that. Now, the other thing I wanted to do is I want this face to be lined up over here, and the part should be 180. So I'm going to create another planar mate, and just select the center of this face, mate connector, select a mate connector in the center of that face. You'll notice the part snaps off of this plane. That's okay because it's just breaking the other constraints to kind of demonstrate where the mate is that you're making. If you want to actually show it where it will really be once all the mates are solved, you can click the solve button and it'll show you, okay, it's still coplanar with this surface. These bottom plane and this top plane are still even with each other. And then this edge is facing this plane. Now I want this to face the other direction, so I'm going to click the flip button, click solve, and that looks more like it. So if I click OK and then close out the dialog, this part can now slide back and forth. It's a little laggy. My internet connection is not happy, but I can slide this part back and forth. And then let's say that we want to go the last step and make this face even with this face. Easy enough. We know how to do that. Planar mate. Pick a mate connector on this face. If it will let me select it. Mate connectors are a little finicky sometimes. Select that mate connector, hit solve. There we go. That's what we want. All right, so we're getting towards the end of this video here. There's one final thing that I want to demonstrate. I'm going to go back to my frame. I'm going to edit, create a sketch on this face, and I'm going to create a circle that is 1.125 inches in diameter. And I don't know, we're just going to kind of create some lines. Oh, I should demonstrate this. I don't know that I've shown this before. Sometimes you have lines in your sketch that you just want to use as guides, but you don't want them to participate in actual geometry. So you can select the line that you want to change, and you click this button up here called construction, and it will change it to a dotted line. And you can't use construction lines or these dotted lines. You can't use these for like extrusions and stuff. They're just there as a guide. Those are super useful. And we're going to show a bunch about how to use these next week. but I figure I should probably introduce the topic here just so you're not caught off guard when we use it next week. So I'm going to set a vertical constraint to that. I just selected the midpoint of this line up here because I just want the hole in the middle. So I don't know, set this length to like 1 or something. So that's kind of like in the middle. And then I'm going to extrude through all, merge scopes, just that part. Okay, cool. All right, so now I've got a hole. So let's go back to the assembly. This part updates. All right, let's open MKCAD. So I'm going to click the MKCAD button. You guys installed this in the week 1. If this MKCAD icon is not there, you have to make sure. Oh, I have to authorize this. Yep. Okay. And then it shows up. We're going to go to bearings. Scroll down to we want this Thunder Hex ID 1.125 OD flange bearing. Click. It'll place it at the origin of your assembly, so it'll just show up. You can collapse the MKCAD panel. Basically, that's how you use MKCAD, right? You scroll through the sections, you find the part you want. There's the search feature up at the top. Basically, you click and it just adds it to your model. Super easy. There's some more complicated stuff that's configurable, but we'll show how to use that later in the CAD class. Okay, so this guy is not constrained, so I can move it around, change its position, move it anywhere I want. And then we have to use mates to attach it. So I just wanted to kind of demonstrate real quick a couple of other mates, and I realize I picked a bad bearing. This is not going to demonstrate this very well. So I'm going to select this and hit delete. So you delete stuff in your assembly. There's a cat trying to get on my lap. Okay, we'll go back to bearings, and I actually I want a hex bearing. It's around here somewhere. 1/2 inch hex, 1.125 OD. That's what we want. Okay, this will demonstrate our point a little bit better because it doesn't have a round board. We'll be able to see it rotate. Okay, so let's start with a fasten mate really easily. Fasten mates on round parts are super useful. So I want this bearing to go into this hole up until the flange touches the outer part. So basically what I'm going to do is I'm going to find a mate connector that is on the underside of the flange and centered on the part. So I can select this edge, you can see the mate connector there kind of in the middle of the screen. I can select this face, which has basically the same mate connector, or this edge. Any of these 3 will work. They're all the same. The big thing to watch out for is if there's like a rounded fillet. This particular model doesn't have one, but if there was a rounded fillet, you got to be careful which edge you select. Otherwise, the bearing will not be perfectly situated on the face of this part. So I'm going to pick this edge here. Didn't select. Like I said, mate connectors, sometimes finicky. Okay, there we go. Just click a bunch of times. Not sure. I think there's some bug there, and I don't know what the deal is. I haven't heard other people complain about it, so I'm wondering if it's something about my computer. But then I'm going to select this guy here. Once again, it won't select. It's facing the wrong direction, so flip it around. Great, cool. Okay, so there we go. There's our fasten mate. That's how you're going to do it most of the time, right? You don't want this to rotate or spin, even though it's a bearing, right? Typically in your models, you're not going to let it rotate because it's just annoying having all your bearings spinning around and facing random angles. Just lock it in place, use a fasten mate. It's a better way to do it. But let's say you did want it to rotate. Like let's delete this fasten mate here, and then this will float out and we can move it again. Let's talk about some other mate types real quick. So let's talk about a revolute. I don't know how you pronounce it, but a revolute mate. This constrains something along an axis and on a plane, but it allows it to rotate. Right? So this is a perfect example. So we're going to select the same mate connectors we did before. This mate connector here and this mate connector here. Come on, there we go. And we're going to click OK, close out. Now this will rotate. Right? I can't pull it out or push it in or change its position, but it can rotate it. So that's what revolute does. Let's delete this and let's demonstrate slider. So what slider kind of does the opposite, right? It doesn't let it rotate, but it does constrain it along an axis. So the key thing here is that if we pick the same 2 mate connectors, click OK. We can slide this part out, but you'll notice if I try to rotate it, I can't rotate it, but I can drag it left and right. It's a little laggy, but I can drag it left and right. But I can't get it to rotate. So the final mate type I want to go over with, and actually I can just edit this and just change the type because I'm selecting the same mate connectors every time. I want to switch this to cylindrical. Cylindrical just constrains it along an axis. It will allow it to slide and rotate. So you'll notice if I drag this out, it's a little laggy, but I can get this to rotate. It'll cooperate. You can see it's rotating. It's super choppy because my internet connection is not giving me a good time right now. But that's what a cylindrical mate does. So that's useful for some things. In a particular, a bearing, it's probably not useful for. So I go back to this, edit, switch it back to fastened. And there's other mate types here. You can mess around with them. Parallel is kind of useful, but that's about the only other one that I've used regularly. Okay, so that concludes our kind of discussion about assemblies. Like I said, you can then take this assembly and place this as a sub-assembly into a bigger assembly, and you can kind of continue the process, but that's basically how it works. So kind of a long videos this week. That's why we broken into 2 segments, so thanks for sticking with it. I will see you guys next week.